Hey guys, here's 1.5, day 1. We're doing transformations in this section. We start off by just a quick review of identifying our parent our parent functions. This will be on your quiz, so be prepared to be able to match all of the functions with the graphs and the name of it. So for this one here, this is a linear equation or a linear function, and the parent function is f of x is equal to x. The second one is the reciprocal. I would also accept rational function because the reciprocal is the basic form of a rational function. That's f of x is equal to 1 over x. This little curvy s guy is a cubic function. That's f of x is equal to x cubed. Moving to our second row. Straight horizontal lines are constant functions because the y value is constant. And so it's going to be f of x is c, where c is some number or some constant. The middle one is a square root function. And that's f of x is equal to square root of x. This last one here, this is a logarithmic function. There's an absolute or non-absolute value. There is a asymptote here. This is the logarithmic function. Doing that all day long. Logarithmic. And that'd be f of x is equal to log x. And on our last row, on the left side, we've got an absolute value. That's a v. V for value is how I remember this one. And so that's f of x is equal to the absolute value of x. On the right-hand side, this is our quadratic, where f of x is equal to x squared. Up top, this is a cubic on its side, so it's the cube root function. So f of x is equal to the cube root of x. And underneath that is the exponential function. And this also has an asymptote. Y equals 0. And this is f of x is equal to 2 to the x. To be able to match the graph to the name to the equation. All right, then we talked about the greatest integer parent function. So this is a new function. You should not know this one. This is brand new to pre-calculus. What the greatest integer says is it's the greatest integer that's less than or equal to our value. So if my value that I'm evaluating is, say, 2.3, the greatest integer that is less than 2.3 would be 2. So it's got to be a whole number that's less than 2.3, and the biggest whole number that's less than 2.3 would be 2. Likewise, if we had 5 1/3, the greatest whole number less than 5 1/3 would be 5, or the greatest integer. If it is some fraction, say a half, the greatest integer less than a half would be 0. And this is where it gets a little tricky to think about, say, maybe negative 4.5. The greatest integer that's less than negative 4.5 would be negative 5. Negative 5 is less than negative 4.5. So often we want to just round that puppy down, make it negative 4. Negative 4 is bigger than negative 4.5. We need the number that's less than negative 4.5. So if it's positive ones, we're just rounding down to 2. And then if it's negative, we're rounding down. But be careful, it's not just the base here. It's actually negative 5, because that's what comes before negative 4.5. This is what that graph looks like. So anything between 0 and 1, my y value is 0. When x is between 1 and 2, my y value is 1. When x is between 2 and 3, the lowest integer there is 2. Notice that the closed dots are when you're on the x value, and then when you're at the next x value, it turns to an open dot, because that's when it steps up to the next step, and then it steps up to the next step. So that's the greatest integer parent function. We're going to do a transformation of it tomorrow, but that's all you really need to know about it just yet. We'll play with it a little bit this year. All right, then it asks us for the characteristics of the parent function, and then f of x is equal to square root of x. So this is the square root parent function. Remember, that's like half of a quadratic parabola that's turned on its side. We can only have half of it because we can't have it down here. That would give us not a function. So our domain for this guy is going from 0 to infinity. We include 0 because we don't have an open circle here. Same thing for my range from 0 to infinity. My y-intercept, where does this graph cross the x-axis? It touches the x-axis here at 0, 0. So that is also my 0 or x-intercept. The x-intercept, y-intercept for this one is the same. Will that always be the case? No, but it works for this one. Symmetry. This guy is not reflected down here, it's not reflected over here, and it's not reflected on the other side of the origin. So we have no symmetry. However, it is continuous on its entire domain, so on 0 to infinity. Which means when I start at 0, I can draw this thing without picking up my pen. My end behavior for the limit as x goes to negative infinity. So when you look at your graph, does x go to negative infinity? Look at your domain. Does it go to negative infinity? It doesn't. So we don't have end behavior when x goes to negative infinity. D and E means does not exist. And where is the limit as x goes to positive infinity of our function? So as x gets bigger, y's are getting bigger too. So it's going to positive infinity. Finally, it's asking where is it increasing, where is it decreasing? My increasing interval, well, when we go left to right, this graph is always increasing. It's always getting bigger. So from, be careful, remember, only parentheses around our increasing and decreasing intervals. So from 0 to infinity is increasing, it's never decreasing. So if you want to write that, for decreasing, never. Or NA doesn't apply. All right, we're going to do the same thing again. This time, my parent function is, hopefully, said absolute value function. So it looks like this. There we go. Our domain for this guy is from 0 to infinity again. Oh, sorry. Whew. Thinking of range. My domain, it goes to negative infinity, it goes to positive infinity, so we're going from negative infinity to infinity. Our range, however, is the same as our square root function. We start at 0 and we go up to positive infinity. Intercepts, just like the last one, our x-intercept is equal to our y-intercept, and that is 1 point. That point is at 0, 0. For this one, we do have symmetry. We are symmetric about which axis, guys? Hopefully said symmetric about the y-axis. So this portion here is a mirror of this portion across the y-axis. It is a continuous function for its entire domain. So continuous on negative infinity to positive infinity. So I can draw this whole graph without picking up my pen. My end behavior, this does have end behavior. It goes to negative infinity, it goes to positive infinity, so I should have end behavior on both sides. So as x goes to negative infinity, here, my y's are going up to positive infinity. And as x goes to positive infinity, as x goes to positive infinity, my y's are going up to positive infinity as well. Finally, where are we increasing, where are we decreasing? So be careful on your quiz. A couple people got this wrong because they weren't reading their graphs left to right. So for our graph, we're always reading left to right. So when we go from left to right, from negative infinity to 0, remember, always parentheses. Oops, put that in the wrong spot. Let's see if I can get it to move. So from negative infinity to 0, we are decreasing. It is going down. From 0 to infinity, we are increasing. And again, always parentheses. At 0, we're neither increasing or decreasing. So that was our parent functions and attributes of our parent functions, just a quick review. And the next video, we're going to review our horizontal shifts and vertical shifts and reflections.